Good evening, everyone. Nice to see you all here. I'm so impressed by the turnout. My name's Robin. I work for Confluent. So Confluent, not Confluence. We're nothing to do with wikis, but we're lots to do with Apache Kafka. So Confluent, one of the companies, contribute to the open source Apache Kafka project. We have our own distribution called Confluent Platform and our own managed service called Confluent Cloud. So out of interest, who's using Kafka today? Like day in, day out, I do Kafka. And who's never ever used it? Okay, and who's kind of like tinkered around with it a little bit, but not much more than that? Okay, good stuff. So this evening, I'm going to talk about something called ksqlDB. It's part of Confluent Platform. I'm not going to go into Kafka in detail itself. So there was a great talk before me about Kafka streams. I will talk briefly about what Kafka is itself, but quite a lot of you know it, and there's a ton of good resources online if you want to learn more about Kafka. So people who know Kafka will know that it's a distributed commit log. If you don't know Kafka, welcome to Kafka. It's based around this commit log. It's an append only, immutable event log. So you produce events to it, and you can consume them off it, but you can't go back and change stuff. It's immutable. And it's distributed, which makes it highly scalable, and you can partition your data for scale and throughput and so on. And that's Kafka in a very small nutshell. But there's a lot more to Kafka than just a distributed commit log. You've got the APIs around it, like the producers and consumers. You've got the integration API with Kafka Connect. And you've got a stream processing API, Kafka Streams, which you heard about previously. So that makes up Apache Kafka. And Kafka itself is an event streaming platform. It's not just a little message bus. It's not like a message broker. It's not kind of like a way to pipe data from like here over into there. Kafka lets you process your data as it passes through. It has built-in integration capabilities. You can do a lot more with Kafka than just kind of like use it as a dumb broker. And the reason you might want to do that is that the data that we work with in Kafka, a lot of the time we need to do things with it. Very rarely does data happen, and then we're done. Okay, sometimes we just want to collect stuff and like chuck it into a black hole that we'll maybe call a data lake or something like that, but most of the time there'll be things we want to do with the data. We want to enrich it, we want to transform it, we want to drive applications from it, we want to analyze it, we want to do stuff to that data. And the data that we're working with in Kafka is events. And events are all around us. Most of the data that we work with in our organization are events. They're human-generated events, like customers phoning up and customers buying things. They're machine-generated events. Like in a factory, you've got like sensors on all the devices. In a network, you've got the firewall, you've got your syslog. All this data around us is events. And so we can use Kafka as our platform through which events flow, and we can process them. And there's a reason why you might want to do that in Kafka. Because when you consume data in Kafka, it's not deleted. Kafka is not like a transient like message bus, and like you read something, you subscribe, and it's gone. With Kafka, you produce an event to it, and it's stored in Kafka until you tell Kafka, OK, I'm done with that. Whether that's based on time or size, or indeed you can store data in Kafka forever if you want to. You can set like the retention super high. You can also use something called compacted topics. But it means that you can process the data and use the data in different ways. So think about a factory. You've got this kind of pretty common data. You've got information about sensors. You've got a timestamp. And you've got some readings. It's a factory that produces widgets. And we want to know, well, what did the widget weigh? And what was the temperature at the time that we produced it? And which machine did it come from? And what time was it? With that data, we can do a bunch of stuff. So we can do things like, well, let's set an alert. If a widget gets produced and the weight is kind of like outside the threshold, we want to know about that. So we need to process that data as it's occurring. I guess we could kind of like process it afterwards and say like, oh yeah, by the way, last week we produced like 10 million useless widgets. Or wait until next month when people start phoning up and returning things, saying like, well, that was not much use. But by analyzing the events as they happen, you can start to pick up these things. But you also want to know, well, what's happening in the factory? How many widgets have we produced this hour? Broken down by production line, what's going on, and like just looking at those numbers. And people want the dashboards, they can see what's going on operationally. Or maybe we want to take it a little step higher, we want to aggregate and see what's going on, what's the temperature across different types of sensors, and maybe we want to say, well, that temperature, if it goes above a certain threshold, we've got a problem with that. And then we also want to use that data, and we're going to put it downstream somewhere. We're going to put it downstream for ad hoc analytics. We're going to put it downstream and use it to train machine learning models. But the data starts off as these events. And sometimes we want to process them straight away, and sometimes we want to process them later, but they start at the same place. So these events that we're going to process, we're going to use stream processing on it. So using the idea of widgets, we've got red widgets and we've got yellow widgets, and these happen over time. Okay, it's an unbounded stream. Maybe the factory kind of like shuts down overnight, but increasingly unlikely nowadays. But streams are unbounded. Events are continuous. It doesn't mean they have to be super fast. We're not talking about like, it's got to be big and fast data for this to be applicable. We're talking about events which happen. Okay? I went to the airport and then I got on the aeroplane, and I can't go back and change that. I can maybe wish I did if it was a crappy flight, but these things are sequential, they're app-end only, and they keep on happening. So it's an unbounded stream of events. And we want to process that stream of events. We want to say, well, of these widgets that we're producing, we've got red widgets, yellow widgets, and I would like to pick out a separate stream just of red widgets. So this is like the most simple example of processing a stream. Some stuff happens, and a dependent application or something else is only interested in a subset of those events. So as they're happening, we can say, well, let's filter those down and just pick out a new stream. We've got an application that wants to subscribe to that stream because it needs to know when a red widget happens. It's not interested in yellow widgets. So we can do that. We can use Kafka streams. We can write ourselves some Java code. We can bring it into our application and start filtering the data that way. And that's great. And lots of people do that. It was a great talk earlier about that. Lots of people use Kafka streams. It's part of Apache Kafka. It's a Java library. It's really cool. It's built on Apache Kafka, so it's distributed, it's scalable. You can lose a node, the work will carry on elsewhere, it will scale out, and so on. Hands up who doesn't code Java. Come on, there must, okay, a few of you. So, room of Java people, brilliant. Kafka streams may well be your go-to, and I'm going to talk about the difference later on. But not everyone codes Java. Maybe you do, but do all the other people in your organization or your customers do? Because a lot more people code in SQL. So what ksqlDB lets you do is use SQL to express the transformations and the processing that you want to do on streams of data. And ksqlDB is built on top of Kafka streams. So everything that you can do in Kafka streams, you can do in ksqlDB. But if you don't code Java, or perhaps if you don't want to code in Java, because this may actually be simpler, you can use SQL to express what you want to do to the streams of data. Because SQL is a very, very powerful and expressive language. It's a declarative language. So if we think about the data and those use cases that we had for it, well, we want to know about the widgets. Okay, if a widget goes over a certain weight, well, we want to say, well, select everything from the inbound stream where the weight is greater than a certain amount. That's a SQL statement. We want to know how many widgets we've produced by production line. Well, that's a SQL statement. Group by this. And that group by there, it could be across everything. It could be broken down by time window as well. We want to analyze it a bit more. We want to build an aggregate and have a predicate on that aggregate. Across all of the different sensors, what was the average temperature? And tell me if it went above 20. So you can use SQL to do these things. So you can process the data as it's arriving. You can build up stateful aggregates using SQL. But you don't always want to process the data straight away. Sometimes you want to put it somewhere else. So within ksqlDB, you can actually say, let's take this stream of data and we'll go and put it over there. We'll write a connector and we'll go and put it into Elasticsearch. Or write a connector and we'll go and put it into HDFS, or S3, or a database, or any number of places. So ksqlDB has this ability to integrate with other systems as well, both pulling data in and pushing data out, like you see there. So ksqlDB is this event streaming database. Hands up who's actually used ksql or ksqlDB? A couple. Come on, hands up. Yeah, a few of you. So some of you used it. So I mentioned then ksql or ksqlDB. If you've never heard of ksql, almost forget that I said it, because it's like it's a naming thing. Naming things is difficult. ksqlDB is the evolution of ksql, and the DB bit on the end and the kind of like the database icon behind it is kind of important, because it signifies what the idea and the rationale behind ksqlDB is. It's not just about stream processing and doing stream processing ETL and kind of like take this and transform it and write it there. It does do that, and it does it very well. But ksqlDB builds on this idea of we have an immutable event log, and these events are built up over time, and we can take those events and we can replay them to give us state. And that state we can query from ksqlDB. So instead of saying we're going to have our events over time and we need to query the state, we'll have to write it somewhere else for our application to query. In ksqlDB, it can actually act as a DB, as a database, and our applications can query that state directly. So that's kind of why it's called ksqlDB now rather than just ksql. So the principle, kind of like from a very high level view, you have a stream of data in Kafka. ksqlDB is about Kafka. You've got your messages in Kafka, we consume the messages from Kafka, and we can process them. We can write some SQL which defines how we want to process that data, and the output of that is a Kafka topic. So we read from a Kafka topic, we write back to a Kafka topic. And we could process it some more. We can daisy chain our processing. Maybe we don't want to optimize too early our pipeline. We want to kind of cleanse the data and write it back because someone else might want to use that cleansed data. And then we aggregate it or we build a different aggregate. So you can daisy chain your statements like that. Maybe we want to take the data and shove it downstream for analytics. So we take the data, we cleanse it, we maybe aggregate it, and then it goes downstream for our ad hoc analytics. Maybe we want to drive applications from it. If we've got our widget stream with red widgets and yellow widgets, we've got an application that needs to be triggered by a red widget. Instead of our application subscribing to that source stream, and it has responsibility for doing that filtering as well, all our application has to do, says, well, you tell me when a red widget happened, and I'll process it. So you can build that stream processor ahead of time and say, well, this is just going to write out red widgets to here, which then triggers the events in that application. But it's not just about taking topics and writing them back. It's also about our applications down here being able to say, well, hi, you're a database. You've got DB on the end, you're a database. I'd like to know, I'd like to query the state. So you can say, well, we've got an inbound stream of events, and it's to do with like transactions against an account, and we've got credits, and we've got debits. We can materialize that state. We can do a sum against the amount grouped by account. And within ksqlDB, driven by the events coming from a Kafka topic, we can materialize and store that state. It's a stateful aggregation, which means that our application can then say, I'd like to do a lookup, a key value lookup. For this particular key, for account ID 42, I'd like to know what the state is. What's the current value? And ksqlDB will say, the current value is this. So instead of our application having to go out somewhere else for its state, that state can come from ksqlDB. So I'd like to show you a demo. The demo is online. All you need is Docker and Docker Compose, and you can try it all out yourselves. The script's there as well. After the demo, I'll talk a bit more about the kind of things you can do with ksqlDB, and then we'll dig into the architecture, and we'll have a little bit of a peek under the covers. But this is an introductory talk. This is not a kind of like, let's dig down into the bits and bytes of it. So I'll do a little bit of that, but not a whole bunch of it. And then we'll do lots and lots of questions at the end. So let me switch screens and have a quick drink. Okay, normally I have to ask, can you read the text at the back? But this projector is awesome, so I presume you can see it. If you can't, there are seats at the front. So like I say, the script for this is online if you want to try it out yourselves. I'm using it to save copy and paste errors, which is always embarrassing in a live demo. The first thing I'm going to do is I'm going to create a stream. So in ksqlDB, we have this concept of streams and also tables. And I'll talk about tables a little bit later on. But in ksqlDB, a stream is pretty much like a Kafka topic, except we've got schema. Schemas are super important. If you've listened to other talks that I've done, I always rant about schemas and their importance. I'm not going to do that too much here, but schemas are important because schemas let us work with sources of data instead of having to kind of like pass around a whole bunch of files before we can actually use that data. So we're going to define the schema on the data, and the stream that we're going to create is going. Do I need to move the screen, the window up? I can see lots of people doing this. If I do that, is that? If I do that, is that okay? Better? Awesome. So it's going to be a stream, and it's going to capture people's movements. It's super creepy. We're going to track people and where they're at. And we've got three fields. We've got the timestamp, when was the reading. We've got the key, which is who's the person who we're tracking, and then we've got the location. So Kafka messages are key value bytes, okay? And also they have a timestamp. So we're going to take advantage of the fact that we've got the metadata within the message for a timestamp, we've got the key within the message that we're going to use for the person. So the only actual value that we need to store here is one, which is just the location. I could have a bunch of other fields there, it just so happens the simple schema that I want fits into those 3 buckets nicely. We're going to use JSON to serialize the data, we could use Avro, we could use CSV if we felt daft. You can also read CSV and JSON and Avro into these. We're going to say we want a single partition because at this point we're creating a topic in Kafka. And the topic we're going to create is called movements. So we say create stream, and now we've created a stream. And I can say show me the streams. And it says here are your streams. You've got one called movements and it's backed by a topic called movements. And if I say show topics, we can see we've got a topic there called movements. Guys, I don't mean to be rude, but if you want to chat, would you mind? Sorry, just because I can okay, thank you. So into our topic, we're going to query it. So we've got a stream, and we're going to say select these values from the topic. So we're going to select the row time, which is the Kafka message timestamp. We're going to use a function. We're in SQL, we can use functions, so we're going to cast the row time, which is an epoch big int, and not many people can read those. We're going to put in something a bit more readable. We're going to take the row key and we're going to alias it to person, and they've got the location. So you'll notice this is pretty much SQL. Before someone asks, it's not ANSI compliant SQL, but it's SQL. And I'm doing things like I'm modifying the schema. I'm saying instead of a column called row key, I'd like you to call it person. And instead of this field here, I'd like you to apply a function to it and reformat it and give it a new column name. So the kind of things that you would do in SQL, you can now do to your messages in Kafka. Select this stuff from movements, and there's this thing here called emit changes. I'll explain all about that later. So, show me all the messages in this topic. And it says, well, okay, press Control-C to interrupt me, but there's nothing much yet. Because we've just created the topic, there's no messages in it. So let's create some messages. So we're going to fire up another instance of ksql. So here I'm using the ksqlDB command line interface, and we're going to do something else, which is nice with ksqlDB. You can insert messages into topics. So instead of using Kafka console, producer, and all that kind of stuff, you can actually do it all within ksql. So insert into movements Robin, and I'm in York. And now up there we see, okay, that stream has now got data. A message arrived on the Kafka topic. I inserted it using ksqlDB, but it's just a Kafka topic. So it could be whatever producer you're using, whether you're in Java or C++ or Python or the REST API, however you're getting data into Kafka, it's into a Kafka topic, and we can now see that within ksqlDB up here. Let's insert another one. I was in Leeds, and then I flew to, well, I got the train because the flight was cancelled, to Brussels, and then I went to Amsterdam. So all of these things are happening. They've got timestamps associated with them. They've got a key, which is me, and we've got the location. So ksqlDB is showing me the values within the topic, but with a schema applied to it. Now, it's SQL, so we can use predicates. So we can say, select all this stuff from movements where the location is Leeds. And because we're not quite sure if people have put uppercase or lowercase or something in between, we can say, well, let's apply a function to that. Okay, so lowercase location is Leeds. And now it says, well, okay, there's nothing. You think, well, hang on, we put Leeds in earlier. It says so there, okay? That's because ksqlDB by default here in my session is saying consume from the latest point in the topic. But Kafka persists data. It stores data in a topic. So what I can say here is, set the offset reset back to earliest. So if you know Kafka, you'll know what I'm doing here. But we can say, instead of starting at the end, start at the beginning of the topic. Which means that when I rerun that query, it says, okay, let's go back to the beginning of the topic and see which messages match that predicate. So we can filter data as it arrives and filter existing data as well. So now if we insert some more data, I was in Amsterdam, and then I came to the lovely city of Kraków, and then I flew back to Leeds, and you can see you pick that up there. So as messages are arriving, it's filtering them, and it writes them up there if it matches that. It's moderately interesting to be able to inspect the data and print it out to the console. It's actually pretty useful if you're trying to debug a system and you want to have a poke around the topic and see, well, we've got this data flowing through. It's either coming in like super fast or it's a really wide topic. Well, with ksqlDB, you can say, well, if it's an Avro, you simply point it at the topic and it picks up the schema from the schema registry. If it's JSON, you have to type it in, which is another good reason to use Avro. But you can then say, from this topic, just show me messages that match this thing I'm interested in, this funny thing that keeps on happening, we can't quite spot it when it's scrolling by, or just show me these particular fields. Out of like 255 fields we've got in the payload, I just want to see these ones here. So you can start inspecting the messages as they pass through, which, as I say, is kind of useful. But more useful is actually being able to write that back into Kafka. So we can do that here. We can say create stream. So this query here, I could simply say create stream foo as. That's all you need to do to write your stream processing application, because now it's going to say create this stream as the output of this select statement. And it's a continuous query. So if I do that, it says, OK, I've created it. We don't see anything on the console because it's an application that's now running in the background. If I say show streams, we've created a stream. And if I say show queries, it's got a query that's running. So this thing is running, and if I say describe extended, it says, OK, I've processed this many messages. And if I give it another message to process, so it's got the leads predicate on it, so we give it another message. We say, look at that. So we process 3 messages. And if I say show topics, we've got a new topic here called foo. And if I say print foo from beginning, it says, well, there are your 3 messages in your Kafka topic. So we've taken the source, we've applied a filter to it, a predicate to it. We've also picked out particular columns that we're interested in. So we've got just these columns here, we've applied that to it, got it in nice format, in a new Kafka topic. And that's now just a Kafka topic that anyone can use. We could continue processing it in ksqlDB. We could hook it up to Kafka Connect and put it somewhere else. We can have an application that is driven by events when someone enters leads, and all that does is it subscribes to that topic, and it's triggered by that event. So I'm actually going to run a slightly different create stream. So this one here, create stream leads users with the Kafka topic. We've changed the Kafka topic name. You don't have to. It'll default to the stream name. And here we're just saying select star. I don't want to change. I don't want to reformat things. I don't want to re-alias things. Just as it is, just pick out those messages, write them to the new topic. OK, so we've created that. Show topics. We've got a new topic called leads users. Print leads users from beginning. And there's the messages as they were. So you've got the key is here. The payload is just the payload as it was before, just the location. And we can show that it's still working. So we change location, doesn't pick it up because it doesn't match the predicate. We enter another one which does match it, and we see that there. Make sense? Cool. What you can also do with ksqlDB is you can build aggregates. So we could say, well, there's this person here, or these lots of people that we're monitoring in a kind of creepy way. How many different times have they changed location? How many different locations have they been to? So if you're thinking SQL, you're thinking count distinct, which is what you can do in ksqlDB. So we can say, oops, I skipped over that and I'll come back to it. So now we're going to create ourselves what's called a table. And I will explain why it's a table in a moment. Called person stats. We're going to say, actually, I'd like to use Avro for my data, because Avro is generally better. I will argue about it afterwards with you if you would like. But you have a schema that goes up into the schema registry. And when you come to use that data, you don't have to type the schema in again. Which I've just got a single value in the payload, a single field in the payload. It's not like a big deal to type in location varchar, but who has like single field payloads? It's like this many, and typing in each time is kind of tedious and error prone. So we're using Avro, and we're going to select these fields from here, and we're going to say select count star, alias as location changes, count distinct on location as unique locations from movements, group by row key, and row key is our person. So we've created that table. Show tables. We've now got a table called person stats. It's backed by a Kafka topic. So these aggregates that we're building are going to a Kafka topic. And that Kafka topic, it's got the key, which is our group by, and we've got the key that we've called out in the statement, the location changes, and the unique locations. And what we can do with that is we can query it. So let's query the table, select the person, the location changes, the unique locations from this aggregate that we've built, and emit changes. I'm going to explain the emit changes magic in a moment. And it says, okay, Robin, he's been to 9 different places, 5 of them are unique. Let's move Robin around a little bit. He goes back to Leeds. Okay, and the location, okay, he's been to 10 different places. Oh, sorry, 10 location changes, but the unique one stays the same. So our table has re-emitted its state because the aggregate changed. So if an aggregate changes, it re-emits it. But we can go back to the table and we can say, what's the current state? And this is where the whole table business comes in. Because the current state for the key, and the key is here is the person, this is the current state. That's the current state of that aggregate. If I change the aggregate, and we go somewhere different, the aggregate will re-emit the state has changed. But if we go back to it and say, what's the current state? It'll say, well, this is the current state. Because in a table, a key has a state. A key has a value. You can have many different keys, but keys have a value. So that's the difference between a table and a stream. So aggregates are tables, because aggregates are for a particular key and optionally for a time window as well, and a value. And they've got multiple values. We've got this value here and that value there. So a table has got the key and the values, but it doesn't have to be an aggregate. You can also say, well, that topic that we had before for movements, and here I'm not creating any new topics, I'm simply saying, I would like you to treat this topic here as if it were a table, which means when I query that table, I want to know what the state is for each key. It's a semantic construct. It's the same stream of data underneath. We've just got different semantics on top of it. So when I select from that table, it says here is the current state. And the current state is going to be me and where I'm at, which matches up with this. I'm in Leeds Town Hall. We go there, and we're going to go to the pub instead. And it says, well, the state has changed. So I re-emit that state. We query the table. What's the current state? And it says, well, the current state is that. That's where they currently are. If I fire up another session and show you querying the same thing against the stream. Okay, so let's make ourselves a bit of space. Now I'm querying the stream. It's the exact same query. Let me show you on here. It's the exact same query, except this says movements T, because it's the table, and this says movements. Both of them are backed by the same Kafka topic, populated by whatever API we're using to get data into a Kafka topic. We're simply saying to ksqlDB, read that topic, and I would like you to model it in different ways when the user asks a question. So we go to the table, and it says, here is the current state. We go to the stream, and it says, here is the stream of events. So the stream of events, you add in a new event, you get the streams. Okay, we forgot to set the offset. Here is the stream of all the different things. And you'll see that the latest one here matches up with the latest one there, because we change the state, you get a new entry in the stream, and the state changes. So this is called the stream table duality. This idea that you can go from a stream and make it into a table that comes from the same data. And if you think about this, all you actually need in your applications is to capture the stream of events. From your stream of events, you can rebuild the state whenever you want. But if all you capture is state, like something happened, I'll write it to a database. Something else happened, I'll write it to a database. That's just lumps of state. So you can't do the cool stuff against the stream, like how many times did they change location? Now you have to like wire up something different to your database to capture the changes and so on. So all you ever need are your events. So we've built this aggregate, and now I'm finally going to explain what on earth emit changes means. So let's go back up to here, and we're going to query person stats. When we query person stats, it's our aggregate table, and it says, here is the current state for this aggregate, and I go and make some changes, and now the aggregate updates, and it emits the change. Because we said emit change, we've subscribed to that stream of changes. Here we're in the console, but your application could subscribe to that. Your application wants to know when the state changes. It gets told that every time the state changes. No events come in, the state doesn't change, there's no notification. But when the state does change, we hear about it, because we said emit changes. And we call this a push query, because those changes get pushed to your application. But we don't always want to do that. Sometimes you simply want to say, what's the current state? We want to do a lookup. Someone's built a little dashboard, they type in a code, they want to say, where's Robin at the moment? And you hit submit, and it's okay, like, let's go and find out where he is. We've got a series of events tracking where Robin is, and ksqlDB materializes that, and it says, okay, here's where they currently are. Or how many times has he moved around? Well, here's the current value. And that's called a pull query, because we're pulling the value from ksqlDB, and we simply get rid of emit changes. We say, well, we don't want you to emit the changes, we just know the current value. This is, well, that's the current value. I move around some more, I go back into leads, and it says, well, okay, my application doesn't know, unless it needs to. It goes back to ksqlDB and says, well, someone still wants to know what the statistics are. It's like, okay, there you go. So it's the state being able to be pulled. And ksqlDB's got a REST API. So our applications can actually, whatever application, whatever language you're using, if it can make REST calls, it can go to ksqlDB to find out the state, to find out the value for a given key. So I'm not a programmer, as you can probably tell, so I hack this all around in curl. So here's my curl call against the REST endpoint here for ksqlDB, and it's just our SQL statement. Select it from here where the row key is that, and then we've got our values. So 14 different changes, 8 unique locations. If we move around some more, and we re-query that state from our application, you can see it's changed. So pull query goes and says to ksqlDB, what's the state? The last thing I want to show you, before we go back to some more slides, is that with ksqlDB, you can connect it to other systems. So hands up who knows of Kafka Connect. Okay, I will come back and I'll do my Kafka Connect talk for you. It's a whole different thing. Kafka Connect is the integration API for Apache Kafka. If you're building systems with Kafka and other technologies, and you're getting data in or getting data out, Kafka Connect should be your go-to starting point for how you do it. Don't start writing things yourself, Kafka Connect does it for you, and you can access these connectors using ksqlDB. So I'm just going to check that the thing's set up, and they are. And what we can do is we can say, well, we've got this series of aggregates in this person stats. So if I say show tables, it says we've got a table called person stats. We've seen that table gets updated every time something changes in the source topic. Well, maybe we want to push that down to a database. Maybe we've got some dashboarding thing that wants to run off a database, or our BI team wants to run reports against it. We can say, well, go and create a connector, create a sync connector. We're going to use the JDBC sync connector. Here's our database, here's how you connect to it, and take this topic. So you create the connector, show connectors, it says, well, it's running, which is jolly good news. And now we can go to Postgres, and we can query the table. So it says, okay, here's this person, here's how many times they've changed location, unique locations. And if I make a change in the topic, and we go back to Postgres, the values have changed. So the topic gets updated, ksqlDB is materializing that into, writing it back into a Kafka topic, but that materialized state we can also access with a pull query, and that Kafka topic we're pushing down to a database. I should probably do some slides instead of just using my hands. So that's what you can do in a nutshell with ksqlDB. The slide, sorry, not the slides, the demo is online. There's the code for it if you want. Let me switch back to this. Okay, so the code's there if you want to. I will put that link and I'll put the slides link on the meetup.com group afterwards. So if you want to get at the slides, you want to get the demo, and all of the other stuff that I've said, I'll send the link for that. I'll put up on the meetup.com group. Also, I'm on, where's my pointer? I'm on Twitter, so if you do Twitter, you can find me there. If I forget a link, send me a tweet, and I'll post it. So that was ksqlDB. I'm never quite sure if slides are better or demos are better for actually kind of getting the point across, so we're going to like go in belts and braces here. So I've shown you the demo, now I'm going to kind of like go through some of the stuff I've shown you as well. So for interacting with ksqlDB, you've got the command line interface, which I use there, I like, the cat likes, And if you used a SQL prompt before in like Oracle or whatever, you'll feel very at home in that. It's just a SQL prompt for running SQL. You can use a web interface, so you can use Confluent Control Center. You can get at this through Confluent Cloud as well. You can use Confluent Control Center for free if you've got a single node Kafka broker. So like you're doing stuff on your laptop, you're just prototyping. If you want to use it across more different nodes, then it's a proprietary thing. Got a REST API that we saw, so you can use that for running queries. You can also use it for defining queries, so as part of your deployment, and I'll talk about that later. And the cool thing is that in the works is a native client. So all of the development for ksqlDB takes place in the open. It's all there on GitHub. And like Kafka has Kafka improvement proposals, KIPs. So people want to change stuff in Kafka, like get rid of Zookeeper, there's a KIP where you can go and read about it. The community discusses it and so on. In ksqlDB, we have clips, which is, again, the community saying, like, should we change this? Should we add in this? I guess there's a design doc. You can go and read all of these. So one of them is about a native client, which sounds pretty cool. I've shown you some of the things that ksqlDB can do. And because it's SQL, there's kind of a ton of stuff that you can do with it. If you can think of it in SQL, ksqlDB can probably do it. And ksqlDB has come on an awful lot in recent months in terms of functionality. So there's been a lot added in as well. You can use ksqlDB for simply changing the schema and transforming your messages. So we saw earlier how you can take a field and you can alias it. You can apply functions to it. You can say, well, I've got a nested structure here, and I would like to flatten that out. Maybe we've got an application downstream. It can only work with flattened data, and we've got structs coming in. ksqlDB can just be that tool in your toolbox that says, select this, flatten it out, and write it back to there. It doesn't have to be super complex stuff. So here we're going to say, well, we've got data. I want to reformat that timestamp, and I want to drop the address field. Okay, we've got address data. It's personally identifiable. It's a GDPR nightmare. We don't want that in our target topic. So you say, well, create stream for orders with no address data, and you just pick out the fields that you do want. And they say, well, also we want to change the timestamp format, so we're going to use that function there, and we'll change the name of the column. And so we change that input message as it arrives and everything that's on the topic to the one that in the structure that we do want it. So you can use it for kind of like wrangling your messages like that. You can also do joins and lookups in ksqlDB. So this is really, really useful, and as a kind of like a principle behind how you do stream processing with Kafka, a lot of the time you'll actually bring in your source data into Kafka and do your joins within Kafka. So instead of saying, I've got a stream of events happening, I've got orders being placed, each order has got an item code, so we've got an item ID over here, and that item ID we need to look up because we want to find out what the item is and what the color is and so on. Instead of saying, like, okay, the event arrives, my application processes it, my application does a call out to a database, and we realize that's really, really slow because we've got like loads of events. So we say, well, maybe we take the database and we're going to cache it within our application, and now we have to maintain a cache. Instead, you say, we take that database and we stream it into a Kafka topic. So now my Kafka topic has a replica of what's in the database. And then within ksqlDB, and same in Kafka streams, you can say, well, just select the values from the two different places, so orders, do an inner join to items on our common key. And then we write out to the target message the order information plus the item information. So you can do these joins within ksqlDB. You can do stream joins, stream table joins, and table joins. All of those are Kafka topics. The only difference is, how do you want to model it? Do you want to model it as a series of events, like an order was placed, another order was placed, another order was placed? Or do you want to model it as if it's kind of like reference data, dimension data, which is a table? What's the value for this key? I showed you in the demo how you can connect ksqlDB to other systems. We saw how you can push data out to a database, but you can also pull in data from other places. Where you can connect data from and to is a huge number of places. So there's hundreds of connectors. If you go to Confluent Hub, you can see all the different connectors that are available, and you can access all of these with ksqlDB. So you've got data in a database, you've got data in message queues, in Rabbit, in Active, and flat files, and REST endpoints. Wherever you've got data, you can stream it into a Kafka topic. And you've got data in a Kafka topic, you can stream it out to numerous places. So you say, create a source connector, create a sync connector, and off you go. If you're not using ksqlDB, but you are integrating with other systems, please look at Kafka Connect. That's my one word of advice, or there'll be lots of words of advice, but that one particularly, please take that away. Kafka Connect is how you should be doing your integration almost all the time. And you can access it using ksqlDB as well, but it's not unique to ksqlDB. Right, let's talk about a bit of theory. You're all very quiet. Has anyone got any questions? Yeah.
So speaking of adoption of this product, so
yeah.
how performant is it? So imagine reality. You got a pretty huge Kafka topic where you accumulated, let's say, hundreds of gigs of data, and you want to calculate some aggregate, let's say taxes, sum of taxes. So, and then you hit this SQL-like query. So, I mean, in terms of latency, what should I get? I mean, my question is very practical. Can I give this tool to the users or build my, I don't know, microservices on top of it? Or it's more like for data analysis or for exploratory, like?
That is a great question. So I'll repeat it if you didn't hear. So let me paraphrase and tell me if I got it wrong. How performant is ksqlDB? And actually, who's ksqlDB for? Is it for my data analysts to kind of like explore the data? Can I use it to build microservices? Is that, okay. So is it performant? Yes. It's built on top of Kafka Streams, which is built on top of Kafka, so it's scalable. So if you've partitioned your data correctly, then you provision ksqlDB in a cluster, which I'll talk about later, and you scale out your processing for throughput like that. Basically, you'd obviously benchmark it and try it out, but that's the principle around how it scales. Who's it for? It is not, in my humble opinion, for ad hoc querying. It's not for you kind of like your data scientists to say, I've got 100 gig of data, I'm going to kind of like run this aggregate or scan through all of this data for like this particular item. It's not for that. It's for building microservices. It's for saying I've got a stream of data that arrives and I want to apply this transformation to it. I want to materialize this state that I can then look up. You can go back and look at the existing data in the topic, so you can kind of like refresh and kind of like reboot your state store. But it's about taking the events as they arrive and maintaining that state and applying those transformations back into a Kafka topic. Does that make sense? Great. Any other questions? Yeah, okay, one here and then there.
Okay, so if you are using the SQL language, right, how do you version that code and how do you deploy it to this cluster?
Excellent question about versioning, which I'll answer later, and if I don't, remind me. Question back there. Okay, that sounds interesting, and we'll come to that at the end if that's all right, because that sounds pretty specific, and I'd love to hear about it. But let's talk more about ksqlDB, and then I love Kafka Connect, so we'll talk about that as well. Whoa, loads of hands. One more, and then I'm going to talk some more, and then we'll do more questions.
So if you're using SQL, what's the transport? You know, it's React, or it's like for example, are you using JDBC connector or something else?
I missed the beginning of the question. Sorry. If you're using SQL.
Yeah. Well, in Java you have the JDBC connector, right, which is sequential. Can you have like a reactive driver for this database?
So at the moment, the API for ksqlDB is a REST API that you can connect to. There's a native client in the works. If you want to read more about that on the GitHub issues page, there's the design document and so on. I'm going to keep on talking, and then I'm going to do some more questions, if that's okay. You seem determined. Go on.
How do you manage the security part in ksql? For example, Kerberos or SSL?
I'll answer that later, if that's okay. Let's keep talking about streams. No one wants to know about streams and tables. I'm determined to talk about streams and tables, so I will, because I'm stood here. I'll answer lots of questions afterwards, okay. So we have a Kafka topic, and Kafka topics are just key value bytes, okay, which is why we need to care about schemas. So within our message, we've got a timestamp, we've aliased the person as a key, and then we've got the value. We've got a ksqlDB stream, and a stream is our topic plus a schema. Because up here, we've just got bytes. So I've said, well, we're going to take it as if it's JSON or something, and we can like deserialize it so we can see it like that. But on the topic, it's just bytes. So we deserialize that. We specify how do you deserialize it. It's Avro, it's JSON, or whatever. So we now have a schema. And we've got a table. And so the table is the same thing. It's a topic with a schema, but it's the value for a given key. It's the latest state for a given key. But it's the same topic underneath. So the message comes in, on the stream we have that, on the table we have that. It kind of looks the same at the moment. But then another message comes in the stream, we can see the update. In the table, the state changes to reflect the change. And then we have more messages come in, the stream shows each of the individual events, the table shows the current state for that key. If we had different keys, if it wasn't just me, I'm ever so narcissistic, it's just me in this, but if there were other people, and the people is the key, then you would see on the table, you would see 2 rows there, or 3 rows there, however many different keys you had, and the value for those rows. And we can also do stateful aggregations. So we can say, with these messages as they come in, I would like to aggregate that. I would like to know how many times has this person moved around, how many different places has this person been to. They're just SQL statements. And as the values come in, the aggregates will re-emit their status. Or they will update their status, and if you're running it as a continuous query, you see that's update. You can also run it as a windowed aggregation. And I didn't show this in the demo, but you can say, instead of going across all the events, which you probably wouldn't always want to do, you can actually say, what's the sum, what's the count, what's the average within a given time frame, within the last hour, within the last 5 minutes, within the last day, whatever. And you can do that with hopping windows and tumbling windows and session windows. And these aggregates, we can persist as a table. And it's a table because it's not a stream, which doesn't actually explain it, but it's not a stream of events. It's the state. And our key for that state is the group by, and if we've windowed it, then it's also the window start time as well. So we can create that table, and that actually gets persisted within ksqlDB within a state store. I'll talk about how very briefly later on. So this state store within ksqlDB, we can query it. We can query it using a pull query. We can actually say, you've got this state. It's almost like saying, like, you've got Oracle, Postgres, MySQL, they hold state, and we can query that state. In ksqlDB, it maintains that state, driven by a Kafka topic, and we can query that state. Now, there are some caveats around that. You have to specify a row key. You can't just, like, say select star and it'll see everything. But if you want to do, like, a key value lookup, you can do that, and that's evolving. Again, check out GitHub to see the progress on that. But you can also do a push query. You can say, just show me every time that aggregate changes, every time a new message arrives that would affect that aggregate, I want to know about that. I want to subscribe to that stream of changes. And so we can access ksqlDB using the REST API, so we can run our pull queries against it. We can say, within my application, what is the current value for this state? And ksqlDB will say, I have a state store. I will give you the answer from that state store, and the answer is 3. So pull query, point in time, and it returns straight away, kind of like going to a regular database. Push query, you subscribe to the stream of changes, and because the changes come from a Kafka topic, and Kafka topics are unbounded, a push query never exits. It's a continuous query until you kill it. So, what some of you have been waiting for, under the covers. This is I should say, brief look under the covers, because this is an introduction to ksqlDB. This is not a deep dive into it. So I'll talk about it a little bit, and then I might do some questions, and I'll probably answer those questions by saying, go and look on GitHub, or join the Slack community, which I'll tell you about later. ksqlDB, at the very, very, very high abstraction, simply consumes from Kafka topics and produces to Kafka topics. That's all it does. But it obviously applies transformations to those, it maintains state, and so it does that using Kafka streams. If you go and actually poke around when this thing's running, it's just Kafka streams topologies under the covers. So if you're at home in Kafka streams, you're kind of you look at ksqlDB when it's running, it's like, oh, I recognize that. Because ksqlDB takes your SQL statement and it runs it as Kafka streams. And it persists the data, the state store, using RocksDB. It runs within a JVM, so it's got the Kafka streams and your RocksDB as a JVM, which means that you can kind of run it wherever you want. You can run it in Confluent Cloud, which we would love you to do as a managed service. You can also run it yourselves. So you can run it on Docker, on Kubernetes, on bare metal, up in the cloud, however you want to do it, and run it yourselves. So if you're running it yourselves, in a moment, you will have to worry about, well, how do I scale it? You can run it as a single node. That's what I've got on my laptop, but you can scale it. So just like you have a Kafka, you wouldn't just have one Kafka broker. You have multiple Kafka brokers for capacity as well as resilience. Kafka Streams applications, you can scale those out. ksqlDB nodes, you can scale those out. So the workload as it's happening, if you've got a source topic and it's partitioned, that will get allocated to different ksqlDB nodes. If one of them dies, the other one picks up the workload. But, very important point, you don't just have a single ksqlDB cluster. Now this gets confusing because we've got DB in the name, and everyone thinks, oh, it's a database, and like we're going to use it for like processing stuff. It's like my data warehouse database. So I've got like one of those, and I'm really worried about what people are going to do and break on it, and we just have to like have one thing. We're not building like a data warehouse database. We're not building just like one big, huge database. We're building applications. So we're building a ksqlDB cluster that satisfies lookup requests from a microservice that we've written that wants to know our orders when they move into a status of completed. We're building a ksqlDB cluster to run a fraud detection process. We're running a ksqlDB cluster for people to like run stuff on and like monkey around with as a sandbox, but that's its own cluster. So we can isolate our workloads because we deploy it as we would do an application. Which also means it's not like one single central thing for people to worry about. Who owns ksqlDB? We don't want to centralize this. Well, you own ksqlDB. Your team, your business division, your project, however you deploy your applications and own your applications, it's just part of your applications. And in terms of deploying it alongside Kafka, you don't always just have one Kafka cluster either. So you maybe have like your primary Kafka cluster and you've got one ksqlDB thing that's running against it for order processing or something like that. But then maybe say we've got a couple of other applications, we don't want those to impact what's happening up here. And ksqlDB is a producer and consumer, so you want to be mindful of what it's going to do on your Kafka cluster, just like any other application would do. So you can say, well, we create separate Kafka clusters, and we're going to use Replicator or something like that in between them. So now we have our events coming in on one, we stream them down to a second one, and our ksqlDB clusters can connect up to that as well. So you think of it very much laid out like that, not just like one Kafka cluster and one ksqlDB cluster. So I said I'd talk about this a little bit. I think I probably answered it already. ksqlDB or Kafka Streams, given that Kafka Streams is how ksqlDB operates, given that when you run a ksqlDB query, it runs it as Kafka Streams, and given that you're all Java coders, why wouldn't you just use Kafka Streams? Well, maybe you will. That's fine. Kafka Streams is brilliant. Maybe you're already using it. Maybe you're a team of Java developers. You use Kafka Streams to do your stream processing. Happy days. But maybe there's other people in the organization who, instead of passing you a specification for, like, can you write this Java program with Kafka Streams to do my stream processing, here's my SQL statement that expresses, I would like to take data from here, drop these fields, and with this predicate, write it back onto Kafka so that I can do something else with it. They can write it in SQL. So now you can other people can write stream processing stuff. And as I showed with the clusters and how you deploy it, you can still isolate things and not let people bugger things up by like running daft things, but now more people have access to stream processing. And also, just as a Java developer, and you may disagree with me on this, writing a single line of SQL and sending it over REST API to your Kafka Streams, ksqlDB cluster may arguably be simpler than having to spin up some boilerplate and deploy a new Java application. Just saying, maybe. Or you can just go down the stack and write your producers and consumers. The whole thing is there available for you. You choose it based on your skill sets, choose it based on like complexity of deployment. An interesting point that kind of bridges the gap at this kind of interface here, certainly in terms of skills available, you want people to be able to write SQL to build these applications, but there's some functionality not available. You've got like bespoke business logic that you can't encapsulate within a SQL statement. You can write that as a UDF. All you clever Java people can write that as a UDF, deploy it to your ksqlDB machines, and now people can still use SQL to write those stream processing applications, but using the UDF. So all of this stuff that we're writing, all of these applications that we're writing, we'd have to kind of like deploy them somehow. So someone was asking about versioning, I think it was you. So the basic process looks like, I'm going to write some stuff, and I'm going to use the web interface, I'm going to use the command line interface. you probably start off with some select statements. Select it from here, select just these ones, use this function with this predicate, figure out your stuff, and then you put on the beginning of it, create stream as. So now your select, instead of writing to your screen, writes it to a stream, which writes it as a Kafka topic, or create table as select. So you've got your statements, and that now forms your code base. You take your SQL file, or your SQL statements, and to actually deploy it into a new environment, use the REST API to issue those statements to your target ksqlDB cluster. That's kind of what you need to do with it. In terms of versioning, this at the moment is not a particularly nice story. If you want to change your code that's running, you basically kill your existing one and start a new one. And it will start either from like where you're currently at in the topic, like the latest, or the earliest. So that at the moment, there isn't a way of saying like, this thing's running, and then we'll like pause it here, we want to change a predicate, or we want to add a new field, and like carry on from where we got to. It's kind of like all or nothing. So that answers it. It's not a very nice answer, but it's an honest answer. You probably start out with a single ksqlDB node, but you can cluster ksqlDB, so you cluster it for scale and availability when you get into kind of like later on mature environments. To monitor it, ksqlDB, you can use Confluent Control Center, just looking at it as consumers. You've got the ksqlDB access there as well within Control Center. There's also JMX, so if that's your thing, you can actually start poking around under the covers and see what's going on there. Hopefully, this has sounded interesting. So I've got some links and stuff like that to share. The first, most important thing is hopefully you have April 27th and 28th already blocked out in your calendars. Kafka Summit's happening in London. There's a discount code you can use there. Again, I'll put that on the meetup group. Kafka Summit is 2 days of talks like this. Talks about like the guts of it, talks about, there's someone here who's doing a talk as well about fraud detection and stream processing. There's loads and loads of really good stuff. So you're into your Kafka, you want to learn more Kafka, come to Kafka Summit in London. If you can't make it to London, or you want to get to it before then, Kafka Tutorials is an online resource you can use, and it's really useful for 2 particular reasons. One is it lays out a lot of the common patterns that you want to do in stream processing, and it says, well, this is how you would do it. But the second reason it's useful is it says, this is how you would do it in ksqlDB, this is how you do it in Kafka Streams, this is how you do it using the raw Kafka API. And now you can choose, well, this looks most appropriate, this looks most appropriate. Or, I don't quite get why I'd use ksqlDB, I'm just going to use Kafka Streams. Well, this is what it actually looks like side by side. Because it goes through the whole story of like, you want to set up your environment, you want to deploy it. So as an actual comparison for, like, I'm just going to use Kafka Streams, well, also have a look at the ksqlDB tab to see what they look like. I mentioned briefly earlier this resource, the Slack group. Who's on the Confluent community Slack group already? Some of you. Okay, more of you should be on it. If you're interested in Kafka, if you're using Kafka already, it's a great community resource. So there's something like 13,000 people on there. There's lots of different channels for ksqlDB, for Kafka Connect, for Kafka internals, for operations. And it's a great place to meet the community. There's Confluent engineers on there. There's a huge number of helpful people in the community. So that's a really good resource. And my final one for you is this. Several of you new to Kafka, if you're using Kafka already, you'll probably learn something from these. You can get these for free off our website. So you scan the QR code or whatever, and you can get all of those to download. So that is my final slide. I'll put all of the slides, they'll be online. I'll put the link on the meetup group. I'll tweet it as well. So with that, thank you very much for coming. Thank you to Virtus Lab for hosting in such a great place. And now, there are lots and lots of questions. So, yes. Actually, no, someone else. You've been already. I'll come to you again. Who else? Okay.
Okay, so I want to go back to the beginning. You said about Java API, and you compared it to KSQL. I want to ask if there are some things that you can do in KSQL, but you cannot do in Java API.
So the question was, are there things you can do in ksqlDB that you cannot do in Kafka Streams? And the answer is a resound no, because ksqlDB is built on Kafka Streams. So everything that you can do in ksqlDB, you can do in the Java API. I suppose actually the Connect integration Like being able to say simply like create this connector. If you're writing a Java program, you would be responsible for that call out to the Kafka Connect API. So again, it just makes it a whole bunch simpler. But because it's built on top of Kafka Streams, everything you can do in ksqlDB, you can do in Kafka Streams. Yeah.
Quite the opposite question. Is there anything that you can do in Kafka Streams that you cannot do in KSQL? Like,
So,
lastly, there was a problem with suppressing messages
Uh-huh.
with those aggregates, and I think there wasn't a feature in KSQL, but there was in Kafka Streams. So you said that now Kafka Streams is a full subset of the features of Kafka Streams are a full subset of KSQL. So yeah, the first question.
yeah. So the question was the inverse, which is, are there things that you can do in Kafka Streams that you cannot do in ksqlDB? And again, the answer is very much yes. So a couple of examples. Suppress, you mentioned. Foreign key joins, you can do in Kafka Streams, you can't do in ksqlDB. You'd have to repartition your data first. So yes, there are things, if only because Kafka Streams gets developed and then ksqlDB has to kind of like build on that. So yes, there are things. So that would be another of the reasons that you would then end up dropping down that list there. You might start off at the top and then say, well, actually, I really need this thing. I'm going to have to drop down to Kafka Streams. So I generally say, like, you start at the top, unless like you're vehemently opposed to like anything that looks like SQL and you just want to write Java and then knock yourselves out. But generally start at the top, and if you find it's not doing what you want to, then by all means move down to Kafka Streams and processor API or DSL or whatever. But so it's different tools, different approaches, but they are very much subsets of each other. So you can do everything using the produce and consumer API, and then you've got Kafka Streams, then you've got ksqlDB. Okay? Okay.
How do you approach testing?
Carefully. On production, yeah. So the question was, how do you, sorry, let me put that back up. How do you approach testing? Within ksqlDB, there is a test runner. So you can define a JSON file that says, here are my inputs, and then here's my SQL statements, and here are my expected outputs. And it says, did it work or not? I think it's work in progress in that there's a REST API as well. So you can imagine stuff being built around that. But with the test runner, you can do an awful lot of it already. Yeah.
So you mentioned that you can run a cluster of those KDBs.
Yep.
And there is a RockDB inside. So do you replicate one-to-one, or do you how do you achieve the
So the question was, you've got ksqlDB and you can have multiple nodes, and you've got RocksDB. How do you deploy that? Is that right?
How you achieve the if one node dies, so you replicate data to other nodes, so they are the same, or we have only two chunks of data. How does it work with the other networks?
So in terms of the RocksDB availability, I'll give my understanding, and Kafka Streams people can correct me if I'm wrong. As I understand it, so within ksqlDB, it's a JVM, it's got the RocksDB within it. When changes are made in RocksDB, it actually uses Kafka as a change log, so that everything that changes there gets written to a Kafka topic, which can then be used to rebuild that state elsewhere. So it's pretty cool, because you're using Kafka as your immutable event log for the transaction log, in effect, for RocksDB. Who's Kafka Streams person in here who can tell me if I'm talking rubbish? Does that sound approximately correct? Yes. We have it officially.
I had a question about REST API.
Just one moment. Does that answer your question?
Kind of.
For a better answer, go to here. There's a Streams channel. There's one of our engineers called Matthias Sachs. Probably you've heard of him. He will give you an awesome answer. The docs are also, the Java docs and so on are also online. There's a lot of material about how that kind of works. I'm not the best person to give it, other than at that kind of like high level.
So to sum up, you said that you don't need RocksDB replication because Kafka by itself, by the changelog, ensures the fault tolerance.
Yes. Yeah.
But each node can have different view on the data.
Yeah, so the data is partitioned across nodes. It's just that if you lose one node that's got one partition on, that would get taken over by another one. Yeah.
I have
Two. Yes.
You can use UDF in only in DB or also in stream?
In streaming? In Kafka Streams, do you mean?
I mean in ksql and in ksqlDB.
So the UDFs we're talking about here are for ksqlDB and thus ksql. Is that what you mean?
Yeah, I mean, I create my UDF.
Yeah.
I deploy my jar on the class path, each node, and I want to create the DB instance and also the ksstream.
No. On your node, where you deploy your jar, you run ksqlDB. Where you run your Kafka Streams application, you run your Kafka Streams application. If you're asking if the jars are like compatible and you could call your UDF from Kafka Streams, I wouldn't know because I'm not a Java guy.
So I have to deploy also on the ksstream node for you.
Well, I don't know if it would even be compatible. I don't know if that would. I suspect it's an interface that's specific to ksqlDB.
Okay. Other thing is regarding the refresh, refresh rate. I use Kafka in my enterprise project now in my company, and we have issues when we are trying to do some joins, but one of two topics didn't get updated. So we have streaming, and maybe this message can be lost. How do you manage that?
So you want to say I've got two streams and you want one to wait until the message arrives on the next one?
Yeah, I think that let's think that we have two topics, A and B, and the production of the topic of the message is faster than the cache refresh. How can ksql manage that?
I don't have an answer for that. So the Slack group is where I'll go and ask that. ksqlDB, hash ksqlDB or hash streams.
Okay.
Okay.
The last thing is about replicas. If you can manage ksqlDB replica in order to avoid to have moments where your cluster is down.
Yeah, so you have multiple nodes, and then if one goes down, the other one takes over.
It's automatically rebalanced.
Right.
Okay.
Yep. Okay, I don't know if he's gone. There was a question at the back, and I put the guy off. He's gone. He got bored. Here and then there.
Okay, so Robin, you mentioned that effectively this ksqlDB is backed by a normal Kafka cluster.
Yes.
Okay, so the question is, whenever I do apply transformation, let's say filters, maybe some map, does it necessarily mean that a new topic will be created for me under the hood? Is all my data properly filtered?
So when you apply a transformation, so the question was, when I apply a transformation, is all of my data filtered? You've got your source topic, you apply a transformation, selects everything from this stream where widget equals foo. And if you say create stream as select, that writes a new topic, and now you've got two topics. You've got an original one, and you've got a transformed one.
With all my data?
The transformed one doesn't have all your data. The transformed one has where the widget equals foo. Your source one is unmodified. We've just consumed from that topic and read it, and anything that matches our predicate, we've picked out the fields that we want, we've transformed it, and written to a new topic, which just has the bits that we want in it.
So effectively it's a new topic, right?
Correct, it's a new topic.
If I chose to go from the beginning,
Yep.
it means that all my data, given this series of transformations, will be copied and transformed and materialized to a new topic.
Right, so if you write a transformation against an existing topic and you say, I want the offset reset to be at the earliest, it will read all of your data and transform it and write it to your new topic. Yeah. Yes?
Last question, quite simple actually. We can have any tips how to manage a repository of the code that you...
Sorry, say again.
Let's say you have quite a big application and you decide to build it with the ksql. So do you have any tips how to manage the code? Actually hold some kind of tips about the structure of the repository, holding some statements.
So the question was, if you're building an application around ksqlDB and you've got lots of statements, any tips on how to structure the repository? No, sorry. As you would design any other application repository. So nothing specific on that. Okay. Someone who's not asked a question. This guy at the back. So if you're not taking part, would you mind chatting outside? Because I can't hear it at the back. When it comes to? You have to define that for me, sorry.
Like specific character values, like
I'm sorry, I don't. Can you say again?
Like LOB, like large objects.
Yeah.
B-lobs or C-lobs.
Yeah.
Can it process, and how fast it can process the ksqlDB?
Ah, I see. So the question, as I understand it, is how does it handle clobs and blobs, like the binary large objects?
Yes, and also like how fast it can handle.
And how fast? So ksqlDB supports various data types, not including clobs and blobs. So the question is kind of moot. It doesn't handle them. You may find that within your clob, you've got a schema that you'd want to apply to it. As for how fast, it's the kind of like piece of string question. You would need to benchmark it. All I can give you is like generic answer, which is you can scale it out. It's built around Kafka and Kafka streams, which are like pretty fast. But I don't have any specific numbers. Does that help? No. Sorry. Okay.
What is the license? Because we talk about community license, but it's hard to do it.
So the question is, what is the license? So Kafka is Apache license. Apache Kafka is Apache 2.0. ksqlDB is Confluent community license, which is not open source because it doesn't adhere to the OSI definition. It is source available. The code's all there on GitHub. If you want like the specifics of it, you can read the license, which is like kind of dry. There's a FAQ as well on our website, which goes through like makes it a bit more human readable.
Yeah. So how on-prem makes money of it?
Say again?
Because if the company that I'm working in wanted to use it, when would it have to start to pay for it? Once it's
So the question is, the company I'm working in, we're using ksqlDB. When do we have to start to pay for it? I am not a lawyer, and I'm not going to give you an answer on camera because I'm not a lawyer. I'm not going to interpret a license for you. I'll happily chat with you afterwards. The FAQ is online. I don't want to give incorrect advice. But please, find me afterwards. Yes?
Regarding push query,
Yep.
how does they work in case of aggregations based on windowing?
So the question is, a push query, how does it work in terms of aggregations based on windowing?
Yeah.
So when you run a windowed aggregate, it will go, if you said like from the earliest, it will apply the windows, you get your output. As messages arrive that would change the windowed aggregate, so that's generally going to be like the current messages, the current window will get restated and re-emitted. If a late arriving message arrives, then the previous window will get updated and thus re-emitted.
So every time that the window arrives to the final count will be emitted?
No, not when the window comes up to the final count. Every time that the window is based on the epoch. So like January, whatever, 1970 or something, midnight. So let's say you've got a 5-minute window. So it's 18 minutes past 8 o'clock now. The window started at 15 minutes past 8. From 15 minutes past 8, there were like 3 messages. We've got 3 messages in that window, and our aggregate will say there were 3 messages. And when a new one comes in, we've now got 4 messages, and it updates that window as it's being built. And then if there are no more messages, then that final emission is the state for that window.
Okay.
It's not like when you go to a database and you say, give me this aggregate, and it's like, here are the final values for all of those aggregate keys. It actually, as the state changes for the key, it emits that new state.
So since ksqlDB has this DB suffix at the end, does it necessarily mean that I get these ACID guarantees maybe?
I missed the last bit, sorry. Does it mean?
ACID,
okay. So the question is, because ksqlDB has got DB on the end, do I get ACID compliance? No. But sometimes you don't actually need it. And there's a really good talk by Martin Kleppmann from one of the Kafka Summit keynotes recently, where he went through and argued that Kafka itself is ACID compliant. And it's an interesting argument. It is. It's an interesting argument, one which I'm not going to attempt to repeat, but the video is online. You go and Google for it, like Kafka Summit, Martin Kleppmann. It's a very interesting look at like what do we actually mean by ACID and how do you handle that in practice. So if you want to kind of like really dig into it, that's a great talk, but at the high level, no, it's not ACID compliant. Right, one more question, and then I'm going to get a beer.
You said that you have plans, you to answer it now. How do you manage ACLs and security stuff like Kerberos?
Ah, yes, I forgot. We had all these questions and I forgot that one. So how do you manage security on ksqlDB? So Confluent platform has got role-based access control, Kafka's got ACLs, and the only answer I can give you, because I don't know in detail, is they all add up to like that's how you secure it, which is a fairly crappy answer, but I know that the pieces of the jigsaw are there. I don't know in detail. If you really want to know, find me afterwards. I can find out and get you an email, or again, Slack, which is why I put this slide there, because it's so useful. Go and ask the question there.
Okay, that was just because in my case, we have different kind of security in terms of the cluster.
Yep.
So in this case, I think that ksqlDB should behave in a different way in terms of different configurations.
Absolutely. Okay, right. I'm going to get a beer. I'll happily chat if people have got more questions. Thank you very much.